All right, this video will go with Wednesday's linear functions and real-world scenarios. So some main things I want to talk about is the independent variable and the dependent variable in part of the slope-intercept. This will be a little put in context in terms of when we use some real-life examples and really discuss what the independent and dependent variable is and how it relates to developing an equation in slope-intercept form. So your independent variable, so we have a couple questions. So what are they? Well, the independent variable is the factor that will determine the outcome. Independent variables are typically, so independent variables are typically things that will relate to the number of something or how many something exists depending on each situation. And based off of that, which is the independent variable, is also your input, will influence what your final result will be, meaning your dependent variable, and that is your outcome or your y in slope-intercept form. The independent and dependent variable are describing what your numbers will be. So we can't look at a number necessarily as an independent variable. We would describe it as more of a descriptor of the number. So you could use the number. So as we get going through this video, I will point that out as we go. So here's our independent variable. Why are they important to know? Well, you got to understand the problem to come up with the equation and kind of understand what you're trying to solve and what you're trying to do. And that's why it's important to understand what the independent variable and the dependent variable are. I usually like to do the dependent variable because sometimes it's easier to understand what the outcome is rather than what is determining, and it almost comes out just naturally. And then how does it help us write an equation? Once we understand the independent and dependent variable, then finding the slope, which is the rate of change, and your y-intercept, which is your starting out point, becomes that much easier. So typically when we have a real world problem, independent variable and dependent variable aren't given usually at the beginning of the scenario. It's usually where maybe it's asked where you choose what your input will be, and then it will give you your output, or it might have a specific number for your inputs that you're going to be using, and that's kind of what we're going to be doing today, and also what your assignment is on the Schoology. So right here is our example. So let's just imagine that you are planning a birthday party. So you're planning your kid's birthday party. Your kid wants to play games, have a bounce house or like a trampoline, or have a paintball. You want the cheapest option depending on the situation. So right now we don't know what is going on except that there might be 15 kids, maybe 25 kids, or possibly 40 kids showing up. So we want to know what our best option is. So we want to figure out what will be our best option for you based off the amount of kids that are coming to the party. So we did some research and we went through and we found that there are 3 different places for each individual one. So first of all, let's talk about the independent variable. So what is going to be our independent variable? Well, in here, we have to know what's going on in each situation here. So our independent variable and dependent variable will be, the independent variable is going to be the number of kids showing up, right? Number of kids showing up. So that number can change. So we gave you 3 options. It's either 15, 25, or 40 kids. So right there's the independent variable. If I wanted to figure out more specifically for 8, I could do that. That would be my new input, which would be my independent variable because it's describing the number of kids showing up. My dependent variable is the total cost. And the majority of the time, your dependent variable is going to be like a total. How much money you spent, or how far did you drive, or those are some of the main scenarios. Our slope, intercept form, remember, is y equals mx plus b. Our independent variable is our x, so that's something that we'll put into our equation, and our dependent variable is the y. That will be our answer, and that's why we have the y is by itself, because that's the outcome. So to use that, we gotta multiply my slope by my input, which in this case would be 15, 25, or 40, and then my y-intercept and plus my y-intercept, or subtract my y-intercept. So my slope, my m, is the rate of change. So rate of change will always be with a per hour, or each day, or every month. There'll be some type of per, each, and every are the three main indicators, or sometimes you might have 5 miles per hour, or you might have something like that where you have a little slash, and that slash means per. So it usually has some type of measurement over a length of time or distance or something like that. So it's always like a per or each or every. So when there's ever anything like that, that is the rate of change. Your B is your y-intercept, and that's your starting out point. What am I starting out with? So like yesterday we had proportion relations. So if you're starting out just straight out from nothing, that would be a proportional relationship, because your y-intercept would be 0. But sometimes you might be like maybe saving money for a particular item, and you might already have $10. Well, your starting out point is $10. Well, so that is not proportional, because each week is not going to necessarily jump up $10. You already have $10 in there. Now, if you're saving $10 a week, it would, but other than that, from first week to the second week, you wouldn't be at $10, you'd be at 20, because you already included the $10. So your proportional graphs always start off at 0. So then it goes up equally each week after that. So again, non-proportion is you already kind of got a head start, so to speak, where you're already off of 0 and you've moved in a different direction. So here's our example here, and our first place that the kid wanted to do is some video games. So Jamie's mobile games. So what we have to do is we've already established what our independent and dependent variable are going to be. So remember, our independent variable is so our x is going to equal number of kids. Our outcome is going to be our total money, total cost. And so we got to figure out our m and our b. So again, like I said before, our m is rate of change. Our b is usually a starting cost or beginning fee. So if we look up here, it has a setup fee. So just for him to show up is $200. So before any kids even come play the video games, it's costing you $200. And then you have one child, it's $205. 2 kids, it's $210, etc. Because then you just keep adding on. So my m is going to be, and here's that word per. So in this case, it's per child. So every child that shows up, it's $5 extra. So my m is going to be 5, and then my slope, my y-intercept is going to be my starting out fee, and that's 200. So now it's easy to fill in the equation, y equals mx plus b, because we know that y is going to be our outcome. Our m is $5 per child, so x, remember, is the number of children, plus our slope, and I mean our y-intercept, which is, it costs $200 just to show up, and there's our equation right there. Now, we got to figure it out for 15, 25, and look at this. Oh, can only allow up to 20 kids. So we need to just figure this one out for 15 kids because I guess the video game people can't have more than 20 kids or else it's just not fun anymore. So this now is my independent variable. So it describes the number of kids, which is 15. Now I'm going to take this 15 and I'm going to put into this equation. And now that 15 becomes my input. So I input it into the equation plus 200, and that equals y. And now I just go through and solve. So 5 times 15 is 75 plus 200 is $275. So for 15 kids, it equals $275. So we can't figure out, this one's not in the running for the 25 kids showing up or the 40 kids showing up. So we'll have to remember that later on. So I'm going to put that one aside. So there, I didn't have to do any extra work. All right. Our next one is jump around. So again, we know our independent variable is number of kids, which is also our x. Our y is our dependent variable, which is total cost. So we got to figure out our m and our d. So again, this is similar to the other one. It has a setup fee, so that's a one-time fee for showing up. The jump around people with their trampolines and bouncy houses, it just costs $150. So that's my y-intercept. So that's where it starts out. And then it's $10 per kid. So I can fill in my equation, mx plus b. So y we're going to solve for. It's $10 per kid, so we don't know how many kids are going to show up, and then it's going to be 150. So now we know that we have 15, 25, or 40 possible kids showing up for this party. So we got to figure out the calculations for each one. So I put this, so now I can do this for, here's my equation, so now I can do the inputs. So these are all my inputs right here. Then what does 15 mean? Number of kids. Now once I put it into the equation, now this is going to, we got to determine our output. Y equals, again it's describing what our dependent is, our total cost. So that's 150 plus 150, so that's 300. So it's $300 for 15 kids. If I put the 20 times 10, I'm just going to kind of simplify this, plus 150, that's 200 plus 150, so it equals $350. Right? Did I do my math right? So, oh crap, we'll do 25 kids, my bad. So that would be 400, that would change that to 250. So that's $400. And then I'm going to just go over here, 10 times 40 plus 150. So that's 400 plus 150. So that's $550 for 40 kids. And that's the key where you guys need to know how to put that stuff in really quick. So I put my independent variable, once it goes into the equation, now it's switching names to input. And whenever we're referring to our x, it's called our number of kids. And our y, once we get an answer for y, that is always referring to our total cost. So when the numbers are in, how do we describe them? And that's the key. Our slope, rate of change, is $10 per child, and my y-intercept, which is my starting out point, is 150 to set up. All right, our third place is paintball they wanted to do. So here, oh, look at that. No setup fee. So that means just showing up, there's no cost. So that would be a proportional relationship because no kids, no show up. But they did give us a little thing. You need to have at least 20. So they're not going to show up and have one kid and just do it for $20 because that would be bad business practice. So we know this is just $20. So again, we have our X is the number of kids, and it has to be at least 20, and our Y is our total cost. Our M now is $20 per child, so you see that has that word per, and our B is 0. So when I write my equation is Y equals 20X. Since this is 0, it does not change. It would just be plus 0, and no matter what I multiply, adding 0 doesn't matter, so we don't need to write that on there. So this is always your key. When you have just Y equals a coefficient and the X variable, that is your dead giveaway that it's a proportional relationship, meaning it will go through the origin, and each increase on your independent variable, it will be equal to the time before. So you're not jumping ahead with the y-intercept. So we don't need to do 15 since it's not enough. So we have 25 and we have 40. So I put my 25 in for the input. And doing the math with these, I know it's going to end up with a 0. And then it's just 2 times 25 is 50. So for 20 kids, for 25 kids, it's going to equal $500. And then I do another one where it's 20 times 40, and then I know there's going to be 2 zeros there, and then it's just 2 times 4, which is 800. You know what I did? When I made this one, I switched that to $15 for my example, so my bad. So we're going to switch that to 15. So if I switch that to 15, that would be $375, and then for 40 kids, it would be 60. My bad. I changed that last minute before I went live on this video, and I forgot to change it on the sheet. So my bad. So now we got to figure out what's the best example for the amount of kids. So we have if 15 kids show up, we have 25 kids show up, or if we have 40 kids show up. So we know at the mobile kids can only be for 15. So the video games for 15 kids is 275. So we have 275 for the games. And for the jump around, we have 300 for the jump. And then there's no paintball can be in this one. So for 15 kids show up, our best option is the video games. That has the lowest cost. Okay, so now for the $25, we know the video games can't be around, so now we have the jumping. So the jumping is 400, and the paintball with my updated is 375. So paint is 375. Is that what I got? Yeah, 375. So here, the paintball is the cheaper version for that one because it has a cheaper cost. Now for the last one, we just again use the jump running around and the paintball. So the paintball is 800, and the jump around is 550, right there. So for 40 people showed up, we would want the jumping house, which would make sense because video games has all that extra stuff. Paintball has all the paint things that you have to do, so it gets more expensive. And then the bouncing house, once you get that. So our best option, depending on the amount of kids, is 15 kids. We'd want to go with the video games. If 25 kids showed up, paintball would be our best option because The video game would be cheaper, but they only hold up to 20 people, so that wouldn't work. And then for 40 kids showed up to jump around, and that makes sense because video games, you wouldn't want 40 kids trying to play video games. You just wouldn't have enough going around. Paintball, 40 kids, it'd be too expensive. That would be around $100. So to jump around, you have a bunch of bouncy things you can do, and that would be the best option. So that's how you use slope intercept form to determine what is the best deal. You have to identify your independent and dependent variables so you know what the numbers are, and then you got to understand what slope and y-intercept. And what I could do is I could have put those on a graph. I could have made tables with those, all the ways and how to represent functions to compare, which would have been a little bit easier at times if we would have done that. But for the sake of your assignment, how I did this is your best option, and then make sure you provide an explanation. Good luck with it, and talk to you soon.